So here we solve problem based on construction of analytic functions by using Miller-Thomson method. First of all, we have to discuss with what is meant by analytic function. Here we know that in complex functions are generally denoted as small f of z, that is equal to u plus ab, that is equal to u plus ab. And here we know that this u is our real part. This is our real part and v is our imaginary part. V is our imaginary part of the given problem. So in construction of analytic function, we using Miller-Thomson method. It has two categories based on the given problem. Either it is real part, that means they give u. We using first formula for finding f of z. Suppose they give imaginary part, means here they give imaginary part. Here they give imaginary part. That means v is given. We using the second formula for finding the coefficient. This is the procedure of to find the analytic function when they give real part and the imaginary part. So these two formula is named as Miller-Thomson method. These two formula is named as Miller-Thomson method. We solve one problem based on construction of analytic function. Actually, this is our given problem. Find the analytic function whose real part is sine 2x by cos h 2y plus cos 2x. So based on the given problem, they give small letter u. That means they give real part. So in this given problem, they give real part. This is the formula of construction of analytic function f of z equal to integral ux of z comma 0 minus I uy of z comma 0. So here you have to find the value of ux. That means partial derivative with respect to x. In our given problem is in the form of u by v. So that means you have to remember that derivative of u by v formula. So that is u by v equal to, we know that u by v equal to, so in that the denominator is v square. Here we have v into u dash minus u into v dash. This is the formula for derivative in the form of u by v concept. So in the given problem, u equal to, in the given problem, u equal to sine 2x, the numerator is sine 2x, denominator is cos h2y, cos h2y plus cos 2x. So this is the given problem. So by applying u by v concept, here cos 2x, that is v square ux of z comma 0, that is ux equal to, so in this denominator v square, that is cos h2y plus cos 2x 2x the whole square. So in the numerator v into u dash, actually the same term in the numerator. So the derivative of this sine 2x is cos 2x into 2, that is cos 2x into 2. minus v into u dash minus u into v dash. Here u is sine 2x, so v dash is in v, the first term is depending with the y, so that it is 0, plus the derivative of cos 2x is minus sine 2x, so minus sine 2x into 2. So this is the derivative. After finding derivative, you have to replace ux of z comma 0. That means x equal to z and y equal to 0 in both numerator and denominator. So this is the term. In the next step, we have to multiply this 2 cos 2z into cos 2z whole square plus 2 sin square 2z. So now you taken out this 2 as common. Remaining is cos square 2z plus sin square 2z. This will be 1. So in that denominator, 1 plus cos 2z the whole square. So that is ux equal to, that is ux of z comma 0 equal to, we get in the numerator is 2 into 1 plus cos 2z. So in that denominator is 1 plus cos 2z the whole square. 1 plus cos 2z the whole square. So now you cancel the common term in both numerator and denominator. Finally we get only 2 divided by 1 plus cos 2z. 1 plus cos 2z. This will be written 1 by 1 plus cos 2z. 1 by 1 plus cos 2z divided by 2. Based on our convenient, we have to change this term is 1 by 1 plus cos 2z divided by 2. In that next term, say 1 plus cos 2z is 2 cos square, that is 1 by 2 cos square 2z divided by 2, that is we get only 2 cos square z by 2. So that is this 2 will be cancelled. Finally we get only 1 by cos square z. So we know that 1 by cos square z is secant square z. That is, this term is secant square z. So this is the value of ux of z comma 0. That is ux of z comma 0 is secant square z. Next step, we find the value of this uy of z comma 0. Next step, we find the uy of z comma 0. This is our u equal to sine 2x divided by cos h2y plus cos 2x by using the same u by v formula. So that is dou u by dou y, that is uy equal to, so v square plus v into u dash, that is denominator is v square v into u dash. So this is a v, So in that numerator we have sine 2x. This is the independent variable of this y. So that means the derivative is 0. So minus sine 2x sine 2x into derivative of this cos h2y plus cos 2x. In this second term, dependent variable is not present. That means this is independent of y. So we can take only first term. That is the derivative of cos h2y is sin h2y. That is sin h2y. So this second term is sin h2y. After finding this uy of z comma 0, then you replace x equal to z and y equal to 0. So in the above step, the numerator having sine t. So that means sine 2z into 0. So whatever the term denominator, we know that sine 0 is 0. So 0 by anything is equal to 0. So 0 by anything is equal to 0. So that means the second value is 0. So now we substitute the values in the Millen-Thomson formula, that is f of z equal to integral ux of z comma 0, ux of z comma 0 dz plus minus I uy of z comma 0 is, we know that 0. So that second term is 0. This second term is entirely 0. So now we have only this first term, that is integral. This term is secant square z. Secant square z into dz. So now we take integral of secant square z. The formula is integral of secant square z is tan z plus integrating constant. So the construction of a multifunction, that is f of z equal to tan z plus c.